Welcome back, 6th grade. I know you're used to opening to a new page in your math notebook, but I actually want you to open to yesterday's page in your math notebook, because if you'll recall, we set it up so we could do the two strategies we're going to learn side by side here. So if you would, please find yesterday's page in your math notebook. And I don't think I had you put this word down, the name of the strategy. The name of the strategy is the algorithm, or the standard algorithm, if you want to call it that. And so we're going to add that strategy to our list today. So go ahead and pause now and just finish off your title on yesterday's page. And when you've done that, close it up and concentrate until we get to redo. Yesterday we looked at a strategy where we made visuals out of here. So we started with this bag of snack mix, you'll recall. And we said, okay, if there's 3/4 of a gallon of it left, we kind of thought of it in 3/4. We said, all right, that's 3/4, 2/4, 1/4 are full. Then we figured out, okay, well, I can switch those to eighths. So if we're making servings of 1/8 of a gallon, 2/8 would fit in a fourth, because 2/8 is equivalent to 1/4. 4/8 is equivalent to 2/4, 6/8 here. And we just used reasoning that we know about fractions and sort of worked it out. And we'd say, well, that's 2/8. There's 1/8, 2/8, 3/8, 4/8, 5/8, 6/8. And we counted 1, 2, 3, 4, 5, 6 servings of Chex Mix. So we knew 3/4 divided by 1/8 equals 6. So that's kind of a long strategy, and it requires you to know precise partitions of fractions. And so I wanted to teach you a second strategy today that is much more just mathy and calculaty, and see what you think. So before we get to that, you have learned algorithms for adding and subtracting fractions and for multiplying them already. An algorithm, if you've never heard that term, is really just like a set of steps. And I'll show you what I mean. It's like a set of rules or steps you follow to do a calculation. So for adding and subtracting fractions in 5th grade, you learn the algorithm kind of works like this. If you wanted to add 1/2 plus 2/3, you learn, well, you can't actually add those because they don't have the same denominator. So you learned to change these into fractions that do have the same denominator, and then you could add them. So in this case, a good common denominator would be 6. 1/2 is 3/6. 2/3 is 4/6. And once their denominators match, now you can add them together. And that would be 7/6 or 1 1/6. Right? So that's the algorithm you learned to add and subtract fractions when you were in 5th grade. It's like the set of steps you follow. Get the denominator the same, then add up the numerators. Right? To multiply fractions, that one had a really easy algorithm. You were going to multiply 1/2 times 2/3. That one, all you had to do was multiply your numerators and multiply your denominators, and that's it. So 1 times 2 is 2, and 2 times 3 is 6, and that's it. 1/2 times 2/3 is 2/6. Can't do it that easily when you add. You can't just add the numerators and denominators, but you can do that when you multiply. So that was the algorithm that you learned to multiply fractions. And today I want to add an algorithm to divide them. So before I show you how to do it, I'm going to tell you how it works, and teach you a new word. So here's how we're going to do this algorithm today. What we're going to do is we're going to call the algorithm for dividing fractions multiply by the reciprocal. Don't write this down. I'll give you a chance to write it when we get to redo. Of the second fraction. Okay? So I need to teach you what that word reciprocal is. But this is going to be our algorithm. Multiply by the reciprocal of the second fraction. Reciprocal is a fancy word for a very easy topic. If I were to pick the fraction, say 3/4, its reciprocal fraction, is simply the numerator and the denominator switched. Its reciprocal fraction is 4/3. if I gave you the fraction, 3/8, its reciprocal fraction is 8/3. You just take the fraction and you switch the numerator and the denominator. So let's get to how that actually helps finally, shall we? So here is our first division problem we did yesterday. We took this bag of snack mix and we figured out that 3/4 divided by 1/8 equals 6. The visual strategy was not easy to do, but it was helpful in understanding the problem and why this would have such a weird answer like 6. So when we switch over to the algorithm, this is just a fast way to calculate 3/4 divided by 1/8. If you can figure out that this is the problem I need to solve, I want to give you a quick set of steps you can follow to do that, rather than drawing the visual, though you're welcome to draw the visual too. So remember what I said before, that the algorithm works like this. Multiply by the reciprocal of the second fraction. So I told you that last time. Now it's time to see how that actually works, right? So what we're going to do, we're going to switch two things in here to do something easier. We're going to change this to multiplying, multiply by, and we're going to switch this to its reciprocal. So rather than doing this math problem, the algorithm to figure out 3/4 divided by 1/8 is to multiply by the reciprocal of the second fraction. So you'll notice I changed the dividing to multiplying, and I changed the 1/8 to 8 wholes. I switched it to 8 wholes. I took its reciprocal. The first fraction stays the same, right? So I multiply, switch, by the reciprocal, switch, of the second fraction. I didn't touch the first fraction. That's how my algorithm works. Keep the first fraction and then multiply it by the reciprocal of the second one. Why that's nice to do is multiplying fractions, as you remember, that is like the easiest possible algorithm to do. 3/4 times 1/8, all I have to do is multiply my numerators and multiply my denominators. Multiplying fractions is very easy, and it's nice to turn it into that. So 3/4 divided by 1/8 is the same as 3/4 times 8 wholes, which is 24/4, which if you think about fourths, so 4/4 makes 1, 8/4 makes 2, 12/4 makes 3, 16/4 makes 4, 20/4 makes 5, and 24/4 makes 6 wholes. So 3/4 divided by 1/8 is 6. And of course, our two strategies need to give us the same answer. It wouldn't make any sense if it didn't, right? All right, let's try one in your notes. So go ahead and find yesterday's example. Yesterday we did this example with the visual model. And it was particularly difficult, right? Because we didn't end up with an exact number of servings. We ended up with like a partial one. So this was a particularly hard one to do with the visual model. Let's see how it goes with the algorithm. So the algorithm to divide two fractions is this. I do want you to write it down this time. It is, I'm already writing it incorrectly. So the algorithm to divide fractions, I'll even put that, to divide, is multiply by the reciprocal of the second fraction. That's all there is to it. Multiply by the reciprocal of the second fraction. And if you think you're going to forget what reciprocal means, you could give yourself like a little, maybe like arrow thing showing that you would like flip it over. I don't know, something like that. Okay? So this problem that we would want to solve is 3/4 divided by 1/10. That's what we want to figure out. 3/4 of a bowl of punch divided into groups of 1/10 of a bowl. So the way I'm going to do that mathematically or with a calculation with an algorithm is to multiply by the reciprocal of the second fraction. So instead of dividing, I'm going to multiply. And I'm also going to take the reciprocal of the second fraction. Those are the two things that change. Multiply by the reciprocal of the second fraction. First fraction doesn't change. So that one's going to stay as 3/4. And now I do that because look how easy that is to do. 3/4 times 1/10. All you have to do when you multiply two fractions is multiply their numerators, multiply their denominators. So I'm going to get 30 on the numerator over 4. And all that's left to do is to figure out what mixed number that is. So when I start counting fourths, 4/4 is 1, 8/4 is 2, 12/4 is 3, 16/4 is 4, 20/4 is 5, 24/4 is 6, 28/4 is 7. I can't go up another set, so I've got 7 whole sets, and I've got 2/4 left. 7 and 2/4, which is the same thing that we found yesterday, if you'll notice. So that is the algorithm to divide fractions. Again, it's something you just kind of have to memorize. It doesn't show you what's happening very well, but it does work much faster and much more easily than the visual strategy. So I always like you to have more than one strategy to count on. So if you're ever working on a problem like this and you're like, I can't remember the algorithm, you have something to go back to. Or if you prefer the visual model and it's just not working out, this one turns out to be too hard, you have another way to go. So having two strategies always leaves you with a backup plan in case your preferred strategy doesn't work or you forget how to do it on a certain problem. All right. So that is the end of that strategy. Hopefully this made good sense to you. If not, please go back and watch the I do and or the we do again, and maybe seeing them a second time will help shore this up in your head before you move on to you do together with your partner. That's it.